Video, I'm going to cover the most important protocol called CoAP, Constrained Application Protocol. So in this video, I'm going to cover these many topics with respect to the CoAP. The first one is basics of CoAP. The second one is CoAP layers. The third one is message types in CoAP. The fourth one is CoAP message format. And the last fifth one is CoAP architecture. So let us begin with basics of CoAP. So here I have taken some statements with respect to the basics of CoAP. CO stands for constrained, AP stands for application protocol. So this protocol is mainly designed to allow a simple devices to join the IoT through the lower bandwidth called the restricted network. The meaning of that restricted network is nothing but it is a constrained node network. A constrained node network actually it is composed of a significant portion of constrained nodes. Mostly these constrained nodes network are deployed in the edge network of an IoT system. So the constrained node networks are deployed in the edge network of IoT. So small devices or simple devices with limited CPU, memory and power resources are called the constrained devices. These constrained devices will be deployed to form a restricted network. In this, how a CoAP works, this is what the meaning of the first statement. And this CoAP is actually designed for the architecture called M2M and machine to machine and IoT applications. So CoAP is an application layer protocol that allows request response model. Then CoAP runs over UDP, user datagram protocol. Then CoAP uses fewer resources than HTTP. So last statement that I have written is CoAP client can use get, put and delete. These are the methods which are used in HTTP, as well as these the same methods will be used by CoAP in order to communicate with one device to another device. So let us take the next slide. So CoAP is also called a client server IoT protocol. So it is very simple. Here I have taken this particular diagram here. Here we have a client and here we have a server. So first, in order to communicate between the client to server, first client will send the signal called request signal to the server. Then after receiving the request signal to the server, server will respond to that particular thing, and from this basis we are calling that CoAP is a client server IoT protocol. The same thing I have taken one more example here. Let us take this is utility operation center, where this particular client wants some temperature sensor value, and this will send the request signal to the temperature sensor, and after receiving the request signal to the temperature sensor, it will respond back to the one more signal called response to that particular client. And let us take the one more slide here about CoAP layers. Here in this CoAP layers, we have two layers. The first one is application layer. Below that we have UDP layer. So application layer, actually it is designed for the communication method based on request response model that we have discussed in the last slide. So it is responsible for the communication based on the request response model, and this UDP is actually deal with the communication of synchronous and asynchronous as well as UDP messages to the upper layer, that is application layer. So these two layers are there in CoAP layers. Now let us look the most important part of the CoAP, message types in CoAP. So here in this CoAP we have four important message types. The first one is confirmable message. It is also called by the name reliable message. It is also called by the name CON. So let me start with this particular diagram. So a confirmable message requires a response, either a positive acknowledgement or negative acknowledgement. So first, in order to communicate between the client and server, what this client do is it will send the signal called CON. CON means confirmable message to the server. Okay. So, and for every message in this CoAP will be having a ID. For example, 0xAA51. So this is a 2-byte address or 16-bit address, you can say. The same ID will be there for CON, as well as if this CON message is received to the server, the same acknowledgement will be given to the client with the same ID. So if the acknowledgement is not received, then retransmissions are made until all the attempts are exhausted. Okay, the acknowledgement message contains the same ID as confirmation message. So let us take this example. Here the CON is nothing but confirmable message is having the ID called 0xAA51, and acknowledgement message is also having the same ID 0xAA51. So at last, if the server has trouble managing the incoming request, if it is having some uh, if it is getting some problem, it can send back a reset message instead of acknowledgement message. For example, if I take this lower figure, here what happens is first client will send CON message, that is confirmable message, to the server, that is called ping. And when this reaches to the this server, if something trouble takes place at the server, it will pong the message, that is RST message will be sent back to the client. So this is the first type of message in CoAP, that is confirmable message. Now let us take the second one, that is called non-confirmable message or unreliable message, or it is written by the term called NON. So here this message is does not require a response in the form of acknowledgement, and it is does not contain any critical information like request for the sensor data in a periodic basis. If for example, let us take the example of sensor, temperature sensor. What it does means it will generate its data uh, continuously. So we can take some samples and we will ignore some other samples. But for all the samples, there will be its respective value. So some samples will be taken into an account, some samples will not be taken into an account. Even if one value is missed, there is not too much impact over there. So even if these messages are unreliable, they have a unique ID. For example, let us take this one, client and server. Here client will send a non stands for non-confirmable message. So I want to take some data from the server, say temperature. So it is having 4D45. It will send back the value 20.1 degrees Celsius from server, which is coming from server to the client. So this is about non-confirmable message. Next, third and fourth message. Third one is acknowledgement message. It is called by ACK. It is sent to acknowledge a confirmable message, CON, as we have discussed in the first message type. And this is fourth, reset, RST. It represents negative acknowledgement. That is, we have seen the second figure of the first message type. It generally indicates some kind of failure, like unreliable to process or receive the data. So this is the most important topic of CoAP, that is message types in CoAP. Now let us discuss about the message format that we have in this CoAP. So first let me take here we have some important terms, that is VER. VER stands for version of the protocol. It is a 2-bit unsigned integer. It mentions CoAP version number. Next, let us take T stands for type. It is of 2-bit unsigned integer. It indicates the message type. For example, we have 4 message types. So these two values equal to 0, then it will be a confirmable. And these two values equal to 1, then it represents non-confirmable. If these two values are equal to 2, then it represents acknowledgement message. If these two are equal to 3, then it is reset message. And next one is token length. So token length is of 4-bit unsigned integer. So it indicates the length of the token, and it represented by here token 0 to 8 bytes. Then here request response code. So here request response code is of 8-bit unsigned integer. It is split into 2 parts. So first 3 bits, the lower 3-bit represents, or MSP 3-bit represents the class, and the MSP most significant bit 8, 9, 10, it represents the class. Then 11, 12, 13, 14, 15, it represents the detailed representation of the code. For example, it may be a method, this response or request code. It may be a method. If it is a method, then it is represented by 0.xx. 0 for empty, 1 for get, 2 for post, 3 for put, like that. And if it is a success message, it is represented by 2.xx. 1 for created, 2 for deleted, 3 for valid, 4 for changed. And if it is a client error, then it is represented by 4.xx. 0 for bad request, 1 for unauthorized, 2 for bad option, 3 for forbidden. Like that, if I take 7.xx, then it is a signaling code. So 0 for unsigned, 1 for CSM, 2 for ping, 3 for pong. Like that, this whole, it represents the class.code, and it is one of the most important part of this CoAP message format, which represents the class and its details. Then comes to the message ID. So this is a 16-bit from 16th to 31 here. So it is a 16-bit unsigned integer used for the matching responses used to detect the message duplication. And here we come options. Options, it specifies the number, the length, and optional value used to specify the target resource of request and proxy function. And here comes the last one, that is payload. Payload is an important data, that is it carries CoAP application data, and it is preceded by 0xFFH. So it indicates the delineate the end of the options. And this is about CoAP message format. Now let us look about CoAP architecture. Here I have taken a very small and very clear picture of CoAP. So here you can see 2 parts over here. The first one is the internet, the normal internet, and here the constrained environment. So here in the internet we have servers, and here we have clients. These clients were connected with the help of HTTP protocol, where in constrained environment all the nodes are connected with the CoAP protocol with this proxy server. So what I can say about this architecture is it extends the normal HTTP clients to the clients having the resource constraints. These clients are also known as CoAP clients. The proxy device bridges gap between this CoAP constrained environment and typical internet based on the HTTP protocol. So this will be acting as a bridge for this internet as well as this constrained environment. The same server, the same server takes care of both this HTTP protocol as well as the CoAP protocol messages. So with this, I'm going to conclude my presentation. Hope this uh, video will be informative to all of you. Please share, like and comment about this video. Thank you one and all.